AI has created huge opportunities for business, but it also comes with a unique energy challenge. The rapid growth of generative AI is dramatically increasing energy demand, while at the same time offering potential solutions to our climate crisis. The energy demands of AI, particularly large language models and generative AI, are staggering. Turns out, large language models have big appetites. The energy needed to train GPT-4 has gone up by a factor of 50 compared to GPT-3, which was already pretty ravenous. According to the World Economic Forum, the computational power needed for sustaining AI's growth is doubling roughly every 100 days. If we look at America, the global leader in AI, recent estimates state that AI data centers could add the equivalent of 3 New York cities worth of load to the US grid in the next 2 years alone. To maintain the pace of growth in generative AI, America alone would need to build 450 new data centers a year up until 2030. These centers require not just enormous quantities of energy, but also consistent and reliable power 24 hours a day, 7 days a week, along with billions of tons of concrete to build them. At this pace, by 2050, data centers would consume 25% of global electricity, creating an immense emissions challenge. This surge in energy demand is pushing tech giants to seek out new clean energy sources. Amazon, Google and Microsoft have all invested in nuclear power sources, with Microsoft joining a global AI infrastructure investment partnership to pour up to $100 billion into power stations, data centers and power infrastructure. It's worth noting that Amazon has a 2040 net zero pledge, Google is aiming for 2030, and Microsoft plans to be carbon negative by 2030. Now, all this assumes that growth in AI models, the data needed and therefore computing power and energy needs, will continue unabated. But this will likely not be the case. The first reason is that further gains in AI capability will likely come from training for different use cases, rather than making models bigger and bigger, given that access to new and diverse data is becoming more difficult. The second reason is simply economics. Developers of Gen AI will need to simply earn back these gigantic investments. This means technology will need to become much more energy efficient, which might happen. Or prices will need to go up, which will limit use. Either way, both will counteract energy growth. But most importantly, don't forget that many organizational benefits will come from rather low energy use of AI. One example is bespoke uses, like good old boring AI that's trained on your data. Now repeat after me. Boring is good for business. Another is the use of open source LLMs, like Meta's Llama. These models are powerful enough for most organizational uses, but their energy thirst is low. You can pretty much run them on your own computer. So, while AI energy hunger is real, it's not without solutions. And who knows? Ozempic for AI might just be around the corner to curb its appetite. While AI is driving up energy demand, it's also offering innovative solutions to optimize our energy grids and accelerate the transition to net zero. AI is being deployed to predict and optimize the performance of renewable energy sources, making them more reliable and efficient. For example, machine learning algorithms are being used to forecast wind patterns and solar intensity, allowing for better integration of these variable energy sources into the grid. AI is also playing a crucial role in energy efficiency and demand management. Smart building systems powered by AI can significantly reduce energy consumption by optimizing heating, cooling, and lighting based on occupancy and usage patterns. In the transportation sector, AI is being used to optimize routes and traffic flow, reducing fuel consumption and emissions. It's crucial to address the energy consumption of AI as part of any business's AI and sustainability strategy. As more organizations develop and deploy AI systems, energy efficiency needs to remain a priority. To achieve this, it takes moves like optimizing algorithms, using more efficient hardware, and considering the environmental impact of using larger models. The challenge of reaching net zero is complex, but with AI as a tool, we have a real shot at developing innovative solutions and creating a more sustainable future.
If we all start using our LLMs in the long run, what impact is that going to have on a transition to net zero?
I'll give you the academic answer. Depends. It depends on the progress we're going to make in energy efficiency of the technologies that run the models, right? Chips and data centers and the like.
I'll give you the economist answer.
I was going to say, and it depends on economics, and I was going to look at you.
I'll give you the economist answer. Currently, the business model doesn't add up.
No.
They're way too expensive. The investment is huge. It's probably the biggest gamble we've taken as humanity on a tech, like trillions of dollars that we're pouring into this.
The business model of the large companies developing.
So it's either going to become a lot more expensive or we'll find ways to drive the energy down because the math just doesn't add up.
Yeah. If the price goes up, usage will come down, energy use will come down. More likely is that we find better ways to run them and also figure out that for most use cases, we might not actually need a large language model, but something that we can run locally.
And that we still have search engines and we still have Excel spreadsheets. We still have a lot of things that do the job.
Do you think this is something important for business leaders to think about?
Well, yes. Because money. At some point, you want to have a cost-effective solution. In the long run, those prices will become sort of attached to the cost of running these models. But also, there's control involved and efficiency. So at some point, you will latch on to the fact that many use cases can be run with smaller, large language models, but locally.
I'm also thinking we need to balance out the need to be quite cautious about how we use them, but we also need to figure out how can this help business. So the innovation angle still needs to be there. Leaders still need to figure out and experiment in their organizations to understand what are the actual possibilities in an environment where everybody else is experimenting. That is their clients, their customers, their stakeholders, their teenagers. Everyone is trying to figure this out. But I do think it's also about having that conversation. While we're really good at having like ROI conversations and other conversations about AI, we're not great at having the energy conversation. And for many countries like Australia, that will be an important conversation going forward, not only in terms of what it will cost the environment to do this, but also what would it take for us to be competitive in that space.
I mean, there's no doubt that AI has lots of use cases and benefits for organizations, transformational potential, but the conversation has to be one that includes the energy question, because you don't want to make yourself dependent with your business model on something that might not be sustainable in the long run. Hence, you need to know what you're doing, so you need to have fluency in your organization to make those decisions.
Yes, AI fluency.
Yeah.
Back where we started.
100%.